Now let's work through a simple example to show how procedures and functions can help to simplify your code and avoid repetition. Let's suppose that you are developing a banking system and it needs to calculate the interest payable on various different types of investment account. Let's assume that your bank offers 3 types of account: a standard account, a silver account and a gold account. The silver account pays 1% more than the standard rate and the gold account pays 2% more. The total interest accrued is calculated as a percentage of the account balance. The bank deducts the same percentages from accounts that are in debt. So when you have money in the account, it earns the specific interest. When you have an overdraft, that same level of interest is deducted. While it would be possible to do these interest calculations separately for each type of account, that would mean that you'd end up repeating an awful lot of code. So not only would you have to do more programming than you really need to, but if you ever needed to change the interest rates and the way they're calculated in future, you'd have to make many, many different changes to your code. And the more recoding that you have to do, the greater is the chance that you'll make a mistake. So for all those reasons, it's better to reduce the amount of code you write in the first place and avoid any unnecessary repetition. Now, when you think about it, you might realize that the code needed to calculate the interest for each of the 3 different types of account, it's essentially the same. Only the percentage rate is different. Now, for that reason, it would make better sense to put a single calculation routine into its own procedure and then just call that single procedure with different values, that's different interest rates, for each of the 3 types of account. Now let's see how I've actually implemented this very simple banking program. This is my Lazarus project. I'll run it so you can see it in action. So it's got a very simple form here and it has a scroll bar at the bottom. So when I scroll the scroll bar, you can see that the amount of money in my bank account is shown in the label on the right. That's 54, 68 and so on. So I've only got limited means, so I only allow myself a maximum of 100, and I can also go into arrears. This is my money going out of the account, and you can see that the label changes to show the money that I haven't got, that I actually owe the bank. And I've got 3 buttons up here, so let's give myself something in my account. The standard one shows me that when I click it, the interest earned on this account at the moment is £2.05. I'm using pounds as I'm in the UK. The same principle would be used, of course, if you're in dollars, euros, or any other type of currency. Click the silver, and it shows me I'm earning a bit more, £2.46, and the gold, £2.87. So let's see what's going on behind the scenes. Right, first of all, this is the method that shows the amount that's in my account. It uses the now familiar int to string int to str function to get the scroll bar position and convert it to a string which can be displayed in the balance label caption. Now all the calculations are done in this routine up here. Let's first of all mention current balance. This is how the current balance is calculated. Again, I use string to int, so I get the caption that was stored in the balance label, and I just convert it from an integer, from a string this time to an integer. So the previous one converted from integer to string, that's when it got the balance as a position on the scroll bar and it wanted to display it. Now I've got the string representation of that value in the label, so when I want to use it in a calculation, I convert it back from a string to an integer using str to int. Now, this is the interesting bit. This is the procedure that actually does the calculation. So, first of all, it sets the standard rate. Standard rate for normal account is 5%, which is probably more than my bank account is earning in real life at the moment. In fact, I know it is, but never mind, we'll look on the bright side and we assume that you're earning 5% on a standard rate account. Then I have these other variables. I got an int rate, and it just adds bonus to standard rate. So bonus is a parameter, it's an argument that's passed, and that shows if there's any additional interest to be added to the standard rate for the different sorts of accounts. Then I calculate the balance. Balance, as I've just explained, is simply looking at the value that was stored in the label and converting it back to an integer. I'm working with integers for simplicity here. In the real world, you'd be dealing with floating point numbers. You'd be having something point, so many dollars and so many cents, so many pounds and so many pence, etc. But for the simplicity of this program, we're sticking to integers, full numbers. So then it calculates the interest earned, which is, now this one is a floating point number because it has to do a calculation using a division by 100. So in this case, I've set int earned to be a double, which is a floating point number. So it multiplies the balance by the interest rate, and it divides it by 100 to calculate the interest. Then the next line just says if interest earned is less than 0, then the message that I want to display is that the interest has been deducted from the account. Otherwise, if it's a positive number, then my message says the interest earned in this account. And then finally, the caption is displayed, which is the message that the interest has either been deducted or earned. And I convert the interest earned figure using this method, float to strf. That's a formatting method. And I just explain what this is, because if you come across standard functions like this, that's functions defined in the code library provided by Free Pascal or Lazarus or Delphi, you may want to look it up. So in Lazarus, I can highlight this and press F1. This is in the Windows version. It shows me references in its documentation. So I select the first one, click OK, and it pops up a documentation window explaining what this function is. So when you come across standard functions, be sure to use the help system to get additional documentations. This just explains that this method takes a value, which is a double, and it has a format. I can link to that to see what it is. The format can be various different types, including currency, which is what I'm using here. So that formats the string to be displayed in a way that looks, in this case, like currency. And the precision, that's the number of the full number and the digits after the number. So be sure to read the documentation for any additional information. Anyway, that's what I've done here. So I've got the interest earned, and I'm formatting it nicely so that it looks like currency, and it's got the full pounds and the pennies, or the full dollars and the cents, displayed as you'd expect them to be displayed. One other thing I've done, because as I am working with sterling, I have to have a pound symbol. Now, it turns out that I need this method to deal with that, otherwise I might get some unexpected sort of symbol. So I can find that in here, and it again explains to me what this method does. But for now, all you have to bear in mind is I've had to use that method in order to convert the floating point to string format, the actual currency symbol that I need to display correctly. These are the three methods that are executed when I click the three buttons. By the way, when I use the term method, I have mentioned this in the documentation. Method is the word that is used to describe a procedure or a function when it's part of an object. So it's an object-oriented term, and we'll be talking about object orientation in more depth later on. For now, if I use the term method, it just means a procedure or a function. So these are the three methods or procedures that are executed when each of the three buttons are clicked. And you can see they're just incredibly simple. They just call calc interest. That's the function that I defined earlier on to do all the interest calculations and display the results. As a result, these three methods just pass the integer, which defines the percentage value to be used when doing the calculations. For my standard button, it just uses the standard rate, so I pass 0. Silver button, it's the standard rate plus 1, so I just pass 1. Gold button, it's the standard rate plus 2, so I just pass 2. Now the advantage of that is that I don't have to have all this calculation code repeated time after time in each of these 3 procedures. If I didn't put it all in one place, in one named procedure, I'd have had to do the calculations for each button, for each account type. I'd have had to repeat it 3 times, once for gold, once for silver, and once for standard. The other advantage is if at a later date I need to modify the rate, I would have to do it all in here, all in the calc interest procedure for the standard rate, and if I needed to change the calculations, I would also do it here. If I needed just to change the interest that was earned, I would just pass it from each of the buttons that call the procedure and send it the bonus amount, that is the amount on the top of the standard rate, to be used in the calculations. So as a result, my code has been simplified. All the important code is in one place. If I need to modify it at a later date, I can find it easily. It's not scattered around all over the code. And it just avoids repetition. It's much easier for the programmer to maintain this code than it would be if there was lots of repetition. I want to emphasize again, these are very simple programs that I'm using, but in a real-world application, in a real-world banking system, there would be many hundreds of thousands, possibly millions of lines of code. It'd be very, very complicated, and the ability to find and maintain that code becomes of far greater significance than in this tiny little sample program. So the principles that I'm explaining in this small program really do apply even more. They're even more important in real-world complicated programs.